Good afternoon, everyone. So, last meeting na tayo ng 130. Thank you for making it this far. Okay, pero hindi pa to yung last recording. No? Baka mag-record pa ako ng additional material kasi hindi pa tapos. Hindi pa tapos yung coverage nito. Okay, so upload ko yun bago mag-New Year. Para din in preparation for your exam on next year. Okay? So ngayon, okay, for the record. Next year na exam, no? January 5. Okay. Para lang nakalagay sa record. Para alam ng iba. Okay, balik tayo sa relativity. Last time, sinabi ko yung mga bagay na hindi ganun kalinaw. Tuloy pa rin po yung mga tuloy pa rin yan para naman mataas yung mga grades niyo. Meron tayong Lorentz transformation but we don't know when to use it or where to use it. Okay? So, yung Lorentz transformation, gagamitin mo siya whenever you're looking at reference frames, okay? Two different reference frames. So, yung may X na frame ka, tsaka yung may bar na mga reference frame. So, yung Lorentz time dilation tsaka yung Lorentz contraction, gagamitin mo siya when you're measuring objects, okay? Measuring an interval or a length, okay? Okay, so baka kasi magkapalit-palit sila, no? Maganda loko-loko. Okay, so you have that. And now let's look at examples for the Lorentz transformations. Example 12.4. Okay, suppose event A occurs at, so gawa tayo. So meron tayong x-axis. This is 0. This is may x, no? Nasa ano tayo, non-moving reference frame. Tapos may event daw at x0. So t0. And another one at some place B. Yung mga triangle ay parang arrows lang. So TA 0, TB 0. Okay? So ito ay somewhere in B. Okay. The two events are simultaneous in S. Okay, siyempre, TA and TB is equal to 0. Therefore, sa paningin ng non-moving reference frame, kung nandito tayo sa linyang to, makikita natin na sabay mangyayari yung dalawang events nito, A and B. Okay? But they are not simultaneous in some reference frame S bar. Okay? So alam na natin to, walang bago dito. Pero tingnan natin kung ano pa yung mapapalaan natin. No? Okay, so let's say we have a moving reference frame. Okay, gumagalaw yun. Okay guys, isipin nyo pwede siyang, okay, ito ay yung 0 point. Pwede siyang, isipin nyo pwede siyang isang cart moving at a speed v. Okay? So isipin nyo sasakyan yan. Tapos yung gitna ng sasakyan, 0 yung coordinate system na. Okay? Okay, then what else? What are our Lorentz transformation? Okay, kung isi-sync natin yung yung events, yung zeroth events, bale yung TA, makikita natin that in here, sync sila, signan nyo. Nasa same position at nasa same time. However, yung B mo, hindi na siya naging simultaneous for the moving reference frame and is given by this formula. Okay? Meron siyang yung position ng given by this, and the time is given by negative gamma b over c squared. Okay? Okay. Okay, now what? Tingnan natin ngayon kung ano yung okay. Ngayon naman, kuwari tumayo tayo dito sa tumayo tayo dito sa position ng center ng reference frame natin. Dito tayo. Tayo tayo dito. Okay. Yan tayo. Ang pangit. Okay yan. Green na lang. Yan tayo. Nakatayo tayo dyan. Tapos papanoorin lang natin yung trend. Kuwari yung trend, meron mga nakaupong tao. Meron mga tao dyan. Okay. May social distancing sila, so 1 unit of space yung tinatayuan nila. Okay. Mga tao ka dyan. And then meron silang clocks. Meron silang clocks. Dala silang clocks. Kuwari ikaw yung nakatayo dito, nakikita mo yung mga orasan sa kamay nila. Mapansin mo na yung, pag ginawa mo yung Lorentz transformation, mapapansin mo na yung mga clocks nila hindi synchronized. Okay. Mapansin mo na yung mga malapit sa unahan, delayed yung oras nila. Tapos yung mga nasa likod, nakaabante yung oras nila. Okay? Kuwari second yung ano niya, second yung kamay niya, okay? Hindi siya minutes, okay? Para drastic yung ano. Mapansin mo, nagsisync lang yung oras mo with the person with the person na nasa tawag dito, katapat mo. Okay? Sipin natin na ano to na negligible yung layo nitong dalawang. Parang ano lang din, para wala yung effects yung pag-triangle ng ilaw. Pero anyway, not related. Okay, what else? Ano pa pwedeng tingnan natin dito? Okay. Ngayon naman, tingnan naman natin yung fun thing dito is tingnan natin yung isang clock sa reference frame, which is this one. Okay? So, tingnan natin tong clock na nandito. Tapos, try natin gawin yung Lorentz transformations. Okay? Tingnan natin equations. Okay, so may equation tayong ganito. T is equal to gamma T bar, then plus V over C squared x bar. Okay? Tapos tingnan natin yung time na mag-elapse sa atin by plugging in what we are looking at. Okay? So kung titingnan natin tong clock na to, mahahanap, pag pinanood lang natin yan, makikita mo yung delta T bar. Tama, di ba? Tapos sa sarili mong clock, may makukuha kang delta T. Tama? So yung delta T would be gamma delta T, tama, plus V over C squared, then delta X bar. Makes sense, di ba? Kasi final minus initial, kunyari yung delta, nakita mo na ganito yung resulting equation kapag minus mo pa to sa isang T is equal to, etc. Okay? Okay, so ganito yung equation mo, and then mapapansin natin na sinabi nga natin na isang clock lang yung pinapanood natin, which is yung X bar equals 8. So, itong clock lang nandito, yung nasa harapan, yung pinapanood mo. Therefore, hindi magbabago yung delta x. Mag-0 to. And what is this? This is your time dilation formula. Which is, ayun yung makukuha mo talaga dapat. Okay? So, pag tinignan mo yung nag-elapse na time doon sa unang sa isang clock na yun, mapapansin mo na dilated yung time, mabagal siya gumalaw with this amount. Okay? So, ayan, yung use ng Lorentz transformation, no? May pinagbabasihan kang reference frames. Okay? So, baka hindi pa ito malinaw agad, pero okay lang yun. Dahil malabo talaga itong mga topic na to, relativity. Kailangan ng practice ng kamay. Kailangan mag-solve. Okay. So, now we try to revisit the twin paradox. Okay, so ano yung twin paradox? Ang twin paradox ay merong twin. Okay. Merong twin na umalis yung twin niya to some place in the universe. Okay. Okay. Then bumalik siya. And napansin niya yung naiwang twin, tumanda siya ng tumanda, tapos nag-travel, bata pa siya. Pero yung storya sa kanya, sa storya nung nag-travel, ang lumayo sa kanya yung stay at home na twin niya. So dapat ang tumanda dapat si traveling twin, di ba? Kasi sa paningin niya nga lumalayo yung tao at some speed. So ayun, no, may conflict between the story sa relativity ng story nila. Kiniklaim nung isa na tumanda, dapat mas tatanda siya, at kiniklaim din naman nung isa na dapat mas tatanda siya. Kasi in both of their reference, kung ano yung napapanood nila, parehas naman sila lumalayo sa isa't isa. So how do we resolve that? Okay, so basahin natin. Merong changes in the specs here. So on their 21st birthday, the one twin gets on a moving sidewalk. So let's try to draw this. So you have your Earth, blue. Then there is a moving sidewalk. Mabilis. Okay, so ayun yung spaceship mo kunyari. Tapos meron kang dalawang moving sidewalk. Okay? And this is your star X. Ayan. So yung speed yung sidewalk, yung walkalator niya, 4 out of 5 na speed of light. Bagal na, no? Basag paa mo nung pag-apak mo pa lang. Pero anyway, kunwari theoretically, kaya natin gawin yun. So sumakay siya, si traveling twin, punta kay Star X, then balik siya agad. Okay. Tapos dumating daw siya on her 39th birthday. Okay, so 39th birthday, so basahin natin agad yun. Ang travel time niya, 21 minus 39 minus 21. This is 18 years of travel time. According to the traveling twin. Okay, so lagay lang natin dito. 18 years of travel time. And then what else? Yung 4/5 the speed of light. We have that. So ano yung gamma natin? Kunin ko lang yung gamma. No? Hindi ko abisado eh. Okay. Yung gamma ay 1 over. Okay. So si gamma ay 1 over square root ng 1 minus v squared c squared. And plugging in the constants that we have, would be nice to learn that this is 1 minus 4 squared, 5 squared, tapos kakancel yung c. Tama? Therefore, this is, yes, kaya ko to. 25 minus 25, tapos 6. Oh my god, 25 din. Siyempre. 25 minus 16. Therefore, this is 9 over 25. 1 over square root now, 9 over 25. Therefore, this is, yes, 5/3. Okay? So we have that. Para lang mas madali. Okay? Alright. So 5/3 yung gamma natin. And let's go. Let's try to solve things. Okay? How old is her twin brother? Okay, so yung kapatid niya stay at home. Therefore, itong 18 years of travel time, that would be due to the time dilation, di ba? So delta t bar is 18. So lagay na natin ito ay si delta t bar. Delta t bar is actually given by 1 over gamma delta t. 1 over gamma delta t. And solving for delta t, we find that ito ay 18. Tapos yung 1 over gamma would be the reciprocal of 5/3. Tama? And that's 3 over 5. Then delta t, solving for delta t, we find that 18 times 5 over 3. Okay? So this is 30. 30 years ba? 30 years yung nag-elapse doon sa oras nung kapatid niya. Okay? Since they are both of the same age, 21st, nung umalis sila naghiwalay sila nung in the past. Therefore, yung age nung lalaki would be 21 plus 30. And that is 51 years old. Okay? So, sobrang gulong-gulo yung gulong-gulo yung sister niya kasi yung sister niya pagbalik lang 39th birthday pa lang ng sister niya tapos yung kapatid niya lalaki 51 na agad. So ano nangyari, 'di ba? Takanta yung So bad trip ngayon si sister kasi sabi nung time dilation, kung sino yung gumagalaw, siya dapat yung dilated yung time. Eh sa paningin niya, yung kapatid yung gumagalaw, yung kapatid niyang lalaki yung gumagalaw. So dapat less than 39 dapat yung aabutan niya. Pero gulat siya, di ba? 51 na. Okay? So you have that. Okay, and then letter B, tinatanong sa atin, gaano kalayo yung si star X? How far is star X? Kung titingnan natin to, this would be, di ba, tumanda si kuya mo ng 30. Therefore, yung kalahati nun, yung papunta doon sa star X. Tama ba? 30 years in total travel time na hinintay nung kuya niya, kapatid niya. Therefore, yung pag pinapanood nung guy yung lalaki niya, yung kapatid niya. So 15 years times kung gaano kabilis yung sidewalk, yung magical sidewalk mo, which is 4 over 5 times the speed of light. And this is 3 times 4, 12 CY, light years. Okay, so 12 CY siya. And then, okay, that's it for this question. Meron siyang may hint si Griffiths no na, okay, gawin nyo to na yung sidewalk system would be bar and inbound system, yung inbound na sidewalk, so yung pabalik na sidewalk would be S bar. So drawing natin yun. So si S of course yung nasa earth, tapos yung S bar would be yung pa ganun, and then yung pa ganito would be S tilde. Okay? So ayan, para madali tayo mamaya. Okay. Now, pagdating ni ate girl doon sa star X, the star X, may gagawin siyang jump, di ba? Tatakbo siya dito, then jump siya pabalik para makasakay doon sa kabila. Okay? So with that, what happens? Anong tinatanong? What are the coordinates of coordinates xt of the jump from outbound to inbound sidewalk in S? Okay, so kung pinapanood ni yung kuya niya, yung pagtalon ng kapatid niyang babae doon, what time at anong location doon? Okay, so the location of that would be easily kung ano yung na-compute niya. How far is star X? Siyempre, doon tatalon yung kapatid niya sa 12 CY. And then yung time mo nan, 15 years. Tama? 15 years? Okay. Make sense, di ba? Make sense pa naman yan. Malinaw pa. Wala pang magic. Now, what are the coordinates of the jump in S? S bar. Okay. The S bar, so X bar, would simply be 0. Kasi nakasakay nasa S bar si ate mo. So therefore, hindi siya gumagalaw at all. So nasa 0 lang siya. Gumagalaw kasi yung coordinate system ng S bar mo. So yung 0 mo gumagalaw din. Hindi naman siya gumalaw. Okay? Pagdating dito sa endpoint, nandun pa rin yung kasabay niya pa rin yung x is equal to 0 niya. Okay? So x bar is equal to 0 na kasabay niya. Okay, and what is the travel time? What is the coordinate of that? Siyempre, yung kalahati ng travel ni girl mo, yung babae. So, yung kalahati no would be 9 years. Okay, medyo magulo na, pero okay. Reasonable. Madali pang isipin. 9 years. Makes sense, di ba? Kasi kalahati ng travel time niya papunta doon sa X. Then, pabalik, another 9 years. Therefore, yung jump niya, yung coordinate ng event na yan would be 9 years. And then, relative to the S bar, X bar, andun pa rin naman yung 0 point niya. Okay, and now, ang magulo dito would be yung coordinates nung ganap na yon in S tilde. So now, kailangan natin gumamit ng Lorentz transformations. Okay? Okay. Ano mangyayari? Kunin natin yung formula for the Lorentz transformations. Okay, may tanong tayo. Okay, how far away is star X? Bakit natin ginamit yung reference point na si lalaki, di ba? Ba't hindi na lang si ate girl? Wait lang. It would be very very confusing for the girl to measure that distance. Alam mo bakit? Kasi gumagalaw siya. Okay, sige, sabihin natin yung time niya okay. Okay. Sige, gamitin niya yung oras niya. 9 years. 9 years of travel time papunta doon. Then, i-measure niya na lang yung distance na na-cover niya. Tama ba? 9 years tapos distance na na-cover niya. So, distance na na-cover niya divided by 9 years would be joke. Distance na joke. Yung time na kinuha niya times yung speed niya, di ba? Okay, anong speed niya? Anong speed ni girl? Wala, di ba? Zero. Kung titignan niya sa sarili niya, hindi naman siya gumagalaw eh. Hindi naman siya gumagalaw, di ba? Gumagalaw lahat ng nasa paligid niya. So, paano niya i-measure yun? And then, kung papanoorin niya naman yung gumagalaw sa paligid niya, napapansin niya na nagko-contract yung length nung gumagalaw ng mga bagay. Dahil they're moving at to the left naman ng 4/5 of the speed of light. Okay, so very very difficult to answer 'yun. Pero okay guys. Bakit kung ganun pala sir, paano natin malalaman kung ano yung totoo? Meron tayong itinatawag na invariant interval. So that tells you how far things are. So invariant 'yun, ibig sabihin, masasolve mo siya kahit sa anong reference frame. That the distance between two events are invariant. Okay, so may way to calculate for the interval or for the distance between two events. Okay, so for now, let's solve it in the easiest way. Okay, so may nakaupo, papanoorin niya lang yung gumalaw. Walang complications doon dahil alam niya sa sarili niya na hindi siya gumagalaw, so walang dilation na nagaganap and walang contraction. Okay? Okay. So, makakalculate natin lahat to no, in yung invariant interval na tinatawag. And it checks out na kahit saan mo siya isolve, kahit sa S bar, S tilde, and in S, mapapansin nyo na same lang yung distance ng star X. Okay. So we have that. Now we go back to this. So sulat natin yung X bar and T bar in terms of the Lorentz transformations formula. Okay, so we have this. Nakikita nyo ba? Okay, so gamma X minus Vt. This is gamma X minus Vt. Then gamma T minus V over C squared X. Yun ba yun? Okay, yun. Okay, so this is the Lorentz transformation with respect to the Earth system. Okay? With respect to the Earth system. Okay, now we solve this. Okay. Tingnan natin muna yung kung ano yung V nature ng V. Okay, so for the S tilde, saan yun? That is the sidewalk that is going to the left. Therefore, we have to switch the signs kasi itong system na ito, sinolve siya na ina-assume na yung motion ng itong coordinates on the left would be moving to the right. Okay? Layo na. Left-hand side na equation. Okay? So, this is actually, plug in natin yung mga bagay, gamma, and then, ano coordinates ng jump? That would be, sige, plug in na natin yung mga bagay. 5/3, ito yung gamma. Then, yung x, 12, ano ba? 12 cy, and then 15y yung isa. Okay. Minus 4/5 speed of light times yung coordinate ng t nung jump would be 15. Why? Okay. So this is actually 15 divided by 5, 3, 24. So 5 over 3 times 24. Hindi ko nasulat yung final answer to I. Wait lang. Fifteen to yes, hindi na gumana yung arithmetic ko. 24 divided by 3, 8 times 5, 40. 40 years. Okay, 40 CY. Tama? 40 CY. And then the other one, so yung x-coordinate nung x tilde coordinate. Nung jump would be 40 CY, 40 light years. And then the time that it occurred would be 5/3. You just plug in things, 15y. 15y minus 4/5 c, c squared. Then this is 12cy. And this is, yes, cancel mga, cancel. 12. Okay. This is 41 years. Calculate nyo na lang. 41 years. 41y. 41 years. Yung coordinate nung jump. So, ang weird, no, na nung jump lang na yun, dito nagme-make sense pa siya na 9 years, after 9 years, saka pa lang siya tumalon. Pero pag pinanood siya dun sa, kapag tumayo ka dun sa kabila, tapos pinanood mo event, mapapansin mo that it happened 41 years. Okay? Okay, eto, tanong natin. Okay. So, tanggapin muna natin to at a face value, no? Parang mahirap ma-convince on these results. Okay. So, ngayon tanong ay, if the traveling twin wants her watch to agree with the clock in S tilde. So, si traveling twin din, naguluhan din siya. Pagtalon niya dun, parang may mali ah. So, anong gagawin niya para ma-reset yung orasan niya after making the jump? Okay? Anong oras ba nung tumalon siya? Ang oras nung tumalon siya would be, on her clock, that would be 18 years of travel time. So, nung tatalon siya, dapat 9 years of travel time. 9 years of travel time. Therefore, to make it up dun sa 41 years na oras dapat nung jump niya, yung legit na jump na doon sa legit na jump. What is legit, di ba? 41 years na nakalagay dun sa S tilde na orasan, dapat ang gagawin niya, dadagdagan niya yung oras-oras niya ng 32 years. Okay? So, dadagdagan niya ngayon, i-adjust niya ngayon yung orasan niya ng 32 years para tawag dito, pumantay doon sa 41 years na nakalagay doon sa orasan ng S tilde. Okay? So, pagdating niya sa bahay, that would be 41 plus 9 years. So, that's 50 years. Okay? Okay? So, yan. 50 years yung mababasa niya sa orasan niya ngayon. Kasi mag-travel pa siya ng 9 years pabalik. Eh, kung in-adjust niya na ngayon yung orasan niya para maging 41 years para lang masatisfy yung orasan sa S tilde, ito yung gagawin niya. Okay? Now, if the traveling twin is asked the question, how old is your brother right now? Anong mare-reply niya dapat? Anong correct reply? According to mathematics, just before she make the jump, bago siya tumalon, and after yung tumalon. Okay, so walang nangyayari, no? Walang biglang bumibilis yung oras or bumabagal nung time na tumalon siya. Pero nagbabago yung ibig sabihin ng right now. Okay? So ano yung reference frame niya nagbabago. Kaya meron changes sa mga oras. Okay, let's try to answer this question. Okay, letter G. Okay, so ang kailangan natin dito, how old is your brother? Therefore, we need the T. Okay? So, kunin natin yung Lorentz formula for this, and this is T over gamma plus V squared plus C squared X. Okay, so we have that. And okay, so in here, ano yung T-bar? Ang T-bar natin would be, okay, coordinate of the jump, 9. Kasi ayun yung tinatanong. Before the jump ang tinatanong. So, 9 years. Before 9 years. And then, X. What is X? Siyempre, position ng kapatid niya. 0. Tama? Di ba? Kasi tinatanong ko ilang taon na siya tinatanong ko ilang taon yung kapatid niyang lalaki. Therefore, this is just, ano gamma natin? 5/3. So, 9 times 3/5. Tama ba? 3/5 ng 9. And this is actually around 5.4 years. Okay? So, this is the time, yung oras na nag-elapse doon sa paningin ni kapatid mong lalaki, 5.4 years, tumalon na yung ate girl niya. Okay? Therefore, ilang taon na yung kapatid niya by that time? So, 21 plus 5.4 years. So, this is actually 26.4 years. Okay? Okay, and this, natuwa dito yung ate girl kasi tama naman na in her POV, gano'n siya katanda nung pagdating niya sa Star X. Gano'n siya katanda pagdating niya sa Star X. 21 plus 9. So, dapat 30 years old siya. 30 years old. Ate. 30 years old before jump. Okay? Jump. And natuwa dito yung ate girl na sa result na ito. Bakit? Kasi sabi niya nga, 'di ba, ang napapanood niya sa sidewalk na 'yon is gumagalaw lahat. Yung kapatid niya, yung Earth, lumalayo sa kanya at 4/5 the speed of light. Okay? Therefore, dapat kapag ganun, gumagalaw yung everything, mapansin niya dapat na yung kapatid niyang lalaki, mas bata sa kanya. And it makes sense kaya siya natuwa. Kasi 26.4 years yung calculation. Okay? Kaya siya na bad trip pagbalik niya kasi 51 years old na. Pero yung calculation niya, 26.4 years pa lang siya nung pagdating niya dun sa start. Okay? Okay, and now what happens between after the jump? Pag talon niyang ganun. Okay, pag talon niyang ganun, what happens? Okay. So, gagamitin naman natin is t. T tilde plus v c squared x. And si x 0 pa rin kasi pinapansin mo pa rin si kuya. Kasi nandun pa rin sa earth yan. x0 pa rin yan. Then, t tilde is something drastic, 41 years old. 41 years, di ba? Tapos gamma, which is 5/3. 3/5 ng 41. And that is around kalahati, 24.6 years. 24.6 years. So we add this to the 21 years old na kuya niya. 21 plus 24.6 years old. And that is 45.6 years old. Yung kapatid niya after making the jump. So doon nagkakatalo, no? So doon umaayos yung math. Okay. May 45.6 years old na jump. May 24.6 years na jump. Nung pagtalon ni ate girl dun sa paglipat niya ng tawag dito, ng platform. Okay? So you have that. So how many Earth years does the return trip take? Okay. Therefore, yung Earth years na kailangan na lang, yung return trip would be, di ba, 45.6 na nga yung yung kuya. Therefore, ang kailangan niya na lang, kasi di ba, pag dumating yung ate niya, 51 years old na siya. Okay? And ilang Earth years na lang yun? So, ito ay dapat 5.4. Okay? 5.4 years. Earth years. 5.4 Earth years. Okay, add this to 2 from G. Okay, baliktad pala ginawa natin. Sinubtract natin doon sa daya. Okay, so pwede mo itong i-calculate gamit yung oras nung 9 years. Di ba may 9 years, 9 years pa napabalik si ate girl mo after the jump? So therefore, pag nag-dilate yung oras niya, dapat ito ay 3/5 nito would be 3/5 nito is 5.4 years. Okay, so ayun yung calculation na na hindi kailangan ng subtraction. Daya kasi natin sinubtract ko lang. Okay, so ika-calculate niya. 9 years yung oras ni ate girl. Ate. Okay, so 9 years orasan niya, pagbalik niya. Pero syempre, tinitingnan niya nga yung tinitingnan niya yung Earth papunta sa kanya ngayon. So dapat, nagda-dilate yung oras ng Earth. So dapat 5.4 years na lang. Okay? Okay, so yun. Okay. So yun, no? Medyo medyo kailangan nyo talaga ng practice para mag-get siya. Kung nalabuan kayo dito, mahirap. Okay? Ito yung dito, yung magic dito, yung sa Lorentz transformations eh. Ano ibig sabihin ng 41 years? Okay? So you try to read your book. Okay. Ano ibig sabihin ng 40 CY? bakit nangyari yun nung nag-jump siya. Okay, so we try to read the book. For now, let's leave it at that. Baka meron pang another revisited na na twin paradox. Alam ko, re-revisit pa to pag ginamit na yung space-time diagrams. Okay? Now, let us continue forward. And ito yung magandang part ng lesson natin ngayon. Is i-introduce ko kasi sa inyo yung 4 vector. The 4 vector. Okay, so meron kang 4 vector, x0, x1, x2, x3. Okay. So ngayon, isusulat natin si x0, the first of the 4 vector, to be ct. Okay. Ang ganda nito equation na to kasi it levels down. It levels down the unit of time to space. Okay, time to space. Okay, so 1 meter of 1 meter ito is equal to the time required for light to cross 1 meter. Okay, so isipin nyo parang ano siya, yung speed of light para siyang na tawag dito. Constant of proportionality. Constant of proportionality para i-balance yung space at time. Okay? And with beta being the relative speed, we can now write the Lorentz transformations as this guy. Okay? So, same pa rin yung notation, yung mga bar para dun sa moving reference frame, and yung mga walang bar would be the rest frame. Okay? So, you have these equations for the Lorentz transforms. Okay? So, ulit lang, yung x0 would be the space-time, and yung x1 to 3 would be the yung space. Space talaga, yung legit na space, yung tangible space. Okay? So you have that. Okay, pansin niyo na sa unang dalawa yung transform yung affected ng dilations and contraction. Kasi si x1 would represent x and x0 would represent time. Okay, so yan. Madali lang to i-derive guys kasi ano siya, straightforward. Okay, so yan, you have your Lorentz transformations like this. And neatly, we can write this down as matrices. Okay guys, marunong pa kayo mag-matrix. So ito, multiply mo dito, multiply mo dito, multiply mo doon, multiply mo doon. Okay, so basically, ihiga mo to dito, ihihiga mo siya doon. Kasi ba pattern yun, no? Para ma-produce yung mga, okay? Tingnan natin yung x0 na bar. X0 bar. X0 bar would be equal to gamma times x0. Nice. Negative beta gamma for your x1. Nice. And then 0 for your x2, 0 for your x3. Okay guys, 1, 1, 2. Sana naaalala nyo pa yung 1, 1, 2 nyo. So ayan. So we can write down the Lorentz transformations in matrix form. Okay, so the 4 vectors are yung mga column vectors mo. Okay? And ito na. Ito yung magandang notation. So you can write this down, this whole thing, as one simple line. So ito ay x bar mu must be equal to the summation ng lambda, capital lambda ito. Lambda yan. Okay? Lambda. Tapos ito ay yung row, then yung column. Okay? Okay, kuha ba yan? Kuha ba yan? Superscript. Yung mu ay yung row, tapos yung nu ay yung column. Okay? Okay. So ngayon, hindi na kayo matatakot magbasa ng relativity ng mga papers about black hole and etc. Kasi ito yung mga yun. Okay. What's nice about this is yung yung Lorentz transformation matrix, lambda, itong Lorentz transformation matrix, lambda, can change, pero yung whole thing, one line pa rin, di ba? So, pwede magbago-bago to depending on your problem. And yung buong equation mo, okay pa rin siya. Isang line lang siya, di ba? Nice. Okay. So, that's your Lorentz transformation in terms of the in terms of this in terms of the four vectors. Okay? Okay. Pero matrix multiplication pa rin yan. Yes, yes, yes. So, magiging ano yan? X bar mu. Actually, hindi na nga eh. Mas madali pala. Sorry. Kung may gusto ka lang initpick, syempre yung representation nito would be still a matrix. But if you want, say, let's get just the x2. And lambda 2 nu nu x nu. Okay, so i-sum nyo lang to. Kailangan nyo lang hanapin yung yung value nito. Okay? So row 2, itong row na to. So ito yung mga values niya. For nu1, nu0, nu1, nu2, nu3. Okay? So x2 must be, ang gagawin natin, let's try to do it. Lambda 2, 0, plus x0 plus lambda 2, 1, x1 plus lambda 3, 1, 3, 2. Mali ang ginagawa ko. 2, 2, sorry, x2 plus lambda 2, 3, x3. Okay? So just need to get lambda 2, 0. So lambda 2, oops, mali. Hindi siya yun. Kasi ang starting point nga pala ay 0. So 2, 0 would be itong part na to. Okay? So 2, 0 is 0. 2, 1 is this guy. 0. 2, 2 is 1. So that's plus x2. Lastly, lambda 2, 3 is 0. Okay. So x bar 2 is just x2. Okay. Okay. So walang transformation na ganap kasi yung x2 natin, di ba, y? Y siya, di ba? Kaya same as the transformation in the other reference frame. Yan na po talaga yung matrix. Hindi. Itong matrix na to is for itong matrix na to is special to, no. This is the Lorentz transform matrix for motion in X. Okay? So pwede magbago-bago yung matrix na yan. Kaya siya sinulat ng ganito. Okay? Para kahit magbago yung matrix na yan, you could write it simply as this guy. Okay? Okay. Ngayon, merong scalar product in merong dot product sa 4 vectors. Vectors pa rin sila, meron silang special na dot product. So yung dot product nila, 'di ba usually A, yan, AB. So AX, BX plus AY, BY. Ito yung usual natin, AY, BY plus AZ BZ. Tama, di ba ganyan? Okay, sa in terms of the 4 vector, ang dot product nitong dalawang to, ang special sa kanya is negative lagi yung zeroth na vector. Okay? So negative 0 B0 plus A1 B1 A2 B2 plus A3 B3. Okay? So sir, di ba ito nakakalito kasi meron kang powers? Paano malalaman? Paano madidistinguish yung x squared sa x squared? Okay. Paano madidistinguish yung 4 vector na x squared tsaka yung normal vector squared? Okay. So hindi gumagamit ng notation na squared dito. Okay guys? Hindi gumagamit ng squared dito. Kasi mga matrix to. It's hard to think of square ng matrix, di ba? So, pag nag-multiply ka, multiply mo with yourself, x mu minus x mu. Wala siyang shorthand notation na magiging 2 mu. Okay, walang ganun. Walang ganyan. Okay, so that's the special thing about your dot product for your 4 vectors. And it's nice kasi invariant siya under rotations. Anong ibig sabihin nun? Na invariant ibig sabihin hindi nagbabago, okay? In tapos variant. Variant nagbabago. In ibig sabihin hindi. Ang ibig sabihin na yung dot product between mu, A mu, B mu, is the same when it is transformed in by Lorentz transformation matrix. Okay, so mu plus mu. Okay? So same lang yan. Okay? Given by this. Okay, so again, yung first value, yung 0, yung time component, temporal component, would be negative pag minultiply mo, pag kinumin dot product. So now we introduce the covariant vector, which is this guy. Covariant vector. Okay. Anong difference nito, sir? Equal lang siya sa this guy, sa normal 4 vector mo. But yung first term is negative. Negative na negative, so positive. Okay? So A mu, this is covariant. Okay, covariant. And yung formal term for this is contravariant. Contravariant vectors. So they are called contravariant vectors. Okay? So when you want to transform this mathematically, you want this, syempre hindi naman tayo focus lang biglang nagna-negative bigla isang term. Hindi pwede yun, di ba? So kailangan mo ng math to do that. You write it down like this. Okay? So A mu is just yung kaninang form times some matrix times yung 4 vector mo. Okay? So this time, bago na yung matrix na nasa gitna, hindi na siya Lorentz transformation matrix, siya na yung Minkowski metric. So Minkowski metric, just is your G, mu, and this is given by this matrix. Okay? Negative 1. Para siyang identity matrix pero negative 1 yung unang entry. Alright? Alright. It's nice, di ba? Hindi na kayo matatakot sa ngayon sa mga pagbabasa ng mga astrophysics na mga papers. Okay? You have this. And then, we have your Einstein summation convention. Okay, so whenever pag pinagtabi natin yung isang covariant tsaka contravariant vector, so we have your A mu, B mu. This is your covariant, this is your contravariant. Or The other way around, kunin mo yung contravariant times the covariant. Ang mangyayari dyan, it would be a summation. Automatic summation siya agad. Okay, kahit wala na nakalagay na ganito. Okay, kaya summation convention siya na shorthand method to do this. Okay, so pag meron kang dalawang quantity na merong Greek letters for both, ibig sabihin nun, nag-multiply ka, nagsasum ka over the indices. So when you do that, you have this inner product. Ito yung kanina, di ba? Okay, so nag-dot product tayo. Parang ganito rin. Bumaba lang yung ibang ano. Bumaba lang yung end din yun. Equal lang sila. Okay? Dito yung formal definition. Okay? Okay? Kaya ganun pa rin. Kaya hindi na sinulat in subscript. Yun nandito. Gets ba yun, guys? Kaya hindi na nilagay na subscript. Kasi similar lang din naman. Okay. Okay. Now, let's try to categorize yung mga summations. Okay? Kapag yung summation mo, yung A mu times, yung covariant times contravariant mo is greater than 0, it's called space-like. Okay? And if, ibig sabihin nun, ano ba yung mga terms mo nandito? Ibig sabihin nun, nag-dominate yung space na coordinates over the temporal coordinates. Diba? Kasi pag positive, mas malaki dapat itong mga positive terms. So they are called space-like. And yung kapag nag-dominate naman itong temporal term, the time, so dapat mas malaking negative, less than 0, they are called time-like. And if for a special case, nag-equal tong dalawang to, nag-0 siya, itong space mo, then yung time mo, nag-equal sila, then it would be called like. Okay? So yung makaka-achieve lang nitong bagay na to is light. Okay? And mamaya, describe natin kung kailan ito makukuha ang space light and time light. So, ano yung mga situation para ma-produce ng space light and time light. Okay? Okay, now we call on the displacement 4 vector, which is just the displacement between two 4 vectors. Okay? So between A and B, ano yung coordinates nun, then kunin mo yung difference nun, that would give you your displacement between those two vectors. Okay? And this is ito yung sinasabi ko na invariant interval. So whenever you take the delta x mu, yung contravariant, multiply mo sa covariant niya, ano mangyayari? So you have this, magiging squared, magiging squared, magiging squared, magiging squared. So ito nakakalito no. May ganun tapos may squared. Okay. So minsan lang nangyayari yan for the same lang. Kasi medyo straightforward naman na pag the same, okay lang mag-squared. Okay? So this is the invariant interval. So this is just d squared. The distance between the two, the space distance between the and the time distance between. Okay, so kapag ginamit mo yung formula na to, it would tawag dito? It would give off the same thing. So kung wari simultaneous yung dalawang bagay, makukuha mo agad yung mag-zero yung t, tapos makukuha mo yung d squared. However, if it's not simultaneous, meron kang difference dito. And makikita mo na invariant siya. So kahit gumagalaw ka or naka-stationary ka, ang interval between those two events would be the same. Okay? So ito yung sinasabi ko kanina na pwede mong isolve yung kanina na D would be the distance, okay? D, distance ng dalawang event. Okay? Distance ng dalawang event. Distance ng dalawang event. Okay? Ito yung sinasabi ko kanina na, di ba, may tanong sa atin kanina about dun sa distance ng Earth tsaka ng star. Ba't hindi na lang siya mineasure with respect dun sa gumagalaw na ate girl? Okay? So, mas mahirap yun kasi kailangan mong alamin tong term na to. Kailangan mong alamin tong term na to para mag-equal yung interval na yun. Okay? Okay. Now, I wanna plug this. Naglagay ng source si Griffiths. I wanna plug this kasi maganda tong librong to. Nabasa ko na siya buo. Amazing. So, space-time physics, if you are very interested in studying special theory and special theory pa lang to, special theory of relativity. Okay? So, if you wanna read this is a nice book. Maganda rin siya. Hindi siya boring. Maganda yung mga ano niya. Hindi siya boring. Madami siyang ano. Tapos nagbibigay pa siya ng mga tawag dito, mga questions na sinasagot niya rin. Confusing questions, tapos sasagutin niya rin. So in the discussion itself, nagbibigay siya ng mga what if questions. What if questions. Tapos sasagutin niya. And it's very helpful for learning. Okay? Alright, so yan, plug lang. Space-time physics. Space-time physics. Okay, the structure of space-time. Punta naman tayo sa space-time diagrams and or Minkowski diagrams. Okay, so when we plot out two events, ginagawa natin siya usually in this discussion as plot mo x mo and then plot mo yung time mo. Okay? So yung speed mo would be kasi di ba ang slope is rise over run. Okay? So kung in terms of this graph, ang rise mo ay t and ang run mo is x. Tama? Kasi rise is t, run is x. So therefore, yung 1 over slope is your velocity. Okay? So you have this. So para makita mo yung, mag-drawing ka ng space-time diagram, para makita mo yung velocity ng isang object, dapat yung kunin mo yung 1 over slope. Okay? So yung velocity ng object, hindi pwedeng mag-exceed ng itong linyang to. Okay? Dahil ito yung speed of light. Kasi di ba inequal footing na natin ngayon yung speed of light with tawag dito, yung unang vector natin. Okay, so dapat yung x0 natin, guys, ct. Therefore, yung x over t, c, kung gagawin mong 1 to, dapat yan, nandito lahat ng drawing mo. So, within your 45-degree angles, yes, 45-degree angles, within that, dito ka lang makakagalaw. Okay? So, ito yon. Ito yung mas magandang drawing. Okay, so itong linyang to would be your present. Kasi, di ba, this is your t is equal to 0 line. Which makes sense, di ba? Kasi present nga siya. And then, yung mga nandito sa above would be your future. And this, and the below is your past. Okay? So, yung linyang na ginagalawan mo is your world line. Ginagamit yan sa mga science fiction, guys, yung world line. Ay, sinasabi nila nag-branch out daw yung world line mo, kaya raw maraming possible dito, outcomes in the future and etc. Okay. Kaya raw may multiverse kasi Kuwari nandito ka sa world line na to, ano mangyayari dito sa world line na to? So infinitely marami kang world line. And those are multiverses, something like that. Science fiction. But who knows? Yeah. Anyway, let's clear this up. Okay. But therefore, hindi ka pwedeng gumanon, no? Hindi ka pwedeng gumanon. Pwede ito. Kasi this is the speed of light. Okay. Okay, now, paano kapag lahat, okay guys, maniniwala ba kayo sa akin na yung mga 3D motions natin pwedeng gawing 2-dimensional? Kuwari, di ba ang one-dimensional motion is going through this line? Paano kapag may stairs? May stairs. Stairs yan, guys. Kuwari. Ayan, stairs yan. Tapos aakyat yung tao. Pupunta siya dito. Okay? So, this is a 3D motion, diba? Tama? You move forward. You move into the page. And then, you move to the left. So, that is XY motion agad yun. Then, tumataas ka. So, that is Z motion. Okay? X, Y, Z. X, Y, Z. Okay? So, yung pagtaas mo, that's your pagtaas mo dun sa stairs, that would be your Z. Tapos yung pag-forward sa stairs, that's your X. Then yung pagpunta mo sa left, that would be your Y. 3D motion siya, di ba? But in a sense, pwede mo i-rotate yung system mo. Pwede mo tignan yung stairs as like this. Okay? Such that, diretso na yung motion mo. Okay? So, punta ka dito. Okay? So, straight line na siya. Tapos, dalawang coordinates na lang. X and Z. Kasi, you move forward and you move, tumataas ka. Mataas yung altitude mo. Okay? So, in essence, you can always make things 2D. And when we do that, in space-time diagrams, magiging 2-dimensional na yung motion mo. Tapos 2-dimensional for motion, then 1 dimension for time. That would give you something like this. Okay? So meron kang, may funnel ka. Funnel. Okay? May funnel ka na. So sa funnel na yan, sa edge ng funnel mo, that is your speed of light. So bawal ka doon. So yung motion lang na gagawin mo would be inside those funnels. Okay? So kapag yung motion mo ay light-like, yung motion mo magsa-stay dito sa mga cups na ito. Okay? Cups na ito. And if it's space-like, ito yung graphs na pwede mong puntahan. Okay? So, pansin nyo sa space-like, nag-exceed siya sa speed of light. Okay? So, ano ibig sabihin ng space-like, tsaka space-like, at tsaka light, time-like, and etc. Okay? Wait lang, may proper term dito. Ito ay yung dinrawing ko dito. Ito ay yung mga na t above 0, t below 0. Ito ay yung mga nasa future mo ay tinatawag na forward light cone. Forward light cone. And then, sa baba, backward light cone. Okay? So, ano ba ibig sabihin ng light-like? Time-like pala muna. Time-like, space-like, and light-like events. Okay? Events. Okay. Mas madaling unahin ko yung example ng space-like events. Okay. Ang space-like events would be, example, um, si si Jello, kumain siya ng brownies. Tapos si Ross, nagsabi siya, uy, ang sarap ng brownies. Okay. Hindi natin alam kung nasan sila. Okay, so, kumari, nasa universe A A, si Jello, kumari Milky Way yan. Universe B, okay, B na lang, si Ross. Universe B, si Ross. Sabi kumain at t is equal 0, at the present moment, si Jello, si G, kumain siya ng brownies. Tapos si Ross, sabi niya, ang sarap ng brownies. At the same moment. No? Same moment in time. Okay, itong universe A and B, they are separated by um, very, very far. Okay. And it looks like na yung events ay related. Okay. Kasi di ba sabi kumain si Jello ng brownies, tapos sabi ni Ross, masarap yung brownies. They would seem like they are related. Actually, parang sabihin mo, they are related events kasi kuwari, pare sila ng brownies na tinutukoy, then somehow they are related. Pero yung relation nila wouldn't be called time-like. Ang tawag sa relation ng events nila is space-like. Kasi hindi mo sila pwedeng connect by a light. Okay? It doesn't, nangyayari sila simultaneously. Or at least, kung hindi man simultaneous, yung news ng pagkain ni Jello ng brownies wouldn't reach Ross even if that news traveled at the speed of light. Okay? Okay? So those are space-like events. So ang space-like events, they are not causally related events. They space-like. So sulat natin. Space-like, not causally related events. Okay? Okay. However, time-like, this is easier, can be causally related. Okay? Can be. Okay? So yung mga time-like events would be the things that are the things that happen due to before and after. Okay? So kuwari yung kapatid mo umutot, tapos naamoy mo siya at some time, those are time-like events kasi they are causally related. Pwedeng mag-travel sa yung news at the speed of light. Okay? Okay. So those are time-like events. Tapos ang light-like events are those events na yung speed of light lang ang makakagawa sa kanya. Okay? So, kuwari may flashlight. May flashlight ka. Event A would be on. Tapos event B, receive. Okay. Kuwari may receiver ka ng ilaw. If they are separated by CT, therefore, these are light-like events. So ang pwede lang makagawa ng event na to would be light. Okay? Kasi nagtravel siya ng speed of light. Okay. So lahat ng events na nangyayari dito, would be light-like events. Okay? Lahat ng nangyayari dito sa loob would be time-like events. And lahat ng nangyayari sa labas, space-like events. Okay? There are other cases syempre na kuwari nangyari at the same time yung event. So those are, of course, space-like events. Okay? Depende sa slope pa rin. Pero on a hindsight, pwede nyo okay, yung difference between time-like and time-like and light-like is that yung light-like, ang makakagawa lang nito would be light. Okay? Two events na separated lang by the speed of light. Okay, kuwari, bigay tayo example. Ano ba magandang example? Okay, lahat ng time-like events, pwede siya maging light-like events. Okay? Pero hindi lahat ng time-like, pwede maging light-like. Gets? Exclusive exclusive lang to for light. Okay? If the two events are separated by the distance or time for light to travel. Okay? So, ang ano ba speed of light? 299 times 10, 2.99 times 10 to the 8. Tama, di ba? Meter per second. Therefore, kuwari ang distance between two events is somewhat 2.98 times 10 to the 8 meter per second. Ay, meters. Okay, so if in 1 second, event A, duration of event A to B is delta t is equal to 1 second, and yung delta x nila is d. Therefore, this event is time-like. Okay? Time-like itong event na to. Distance from event A to event B. So, time-like siya kasi ang distance na lang ay less than the traveled distance of the speed of light, okay, in 1 second. Okay, however, ito ay time-like. So for a special case na event A to B is still the same, 1 second, for 1 second. Tapos titignan mo ngayon yung distance ng events nila, and it would be C times 1 second. And this is light. Kasi si light lang makakagawa nito. Ng event na yan. So, siya lang makaka-reach ng event na yan. However, if yung A to B mo, for 1 second again, tapos yung delta x mo is C plus 1. Hindi na siya mangyayari kasi this is farther than the space-like event na to. Hindi na kayang i-travel ng light to for 1 second. Okay? Kasi it cannot exceed the speed of light. Okay, gets. So those are your time like, light like, space like events. Hindi pa tapos dito yung ano natin, coverage natin. So magse-send pa ako ng additional tawag dito. Additional lectures para ma-cover natin yung up to your exam. Okay, so again, your exam will be on January 5 and bonus prob sets will be given para mapataas niyo pa yung grade niyo. Okay? So kapag meron tayong moving, kuwari may gumagalaw yung space-time diagram mo. Minsan makita nyo, yung space-time diagram ay skewed. So may mga example sa libro na skewed yung space-time diagram. Siyempre, of course, yung slope pa rin nito would be 1. Pero ito, decrease na yung slope. Okay? And then plug ko ulit yung libro kasi maganda talaga siya, guys. Okay? Kung may plans kayo mag-theoretical physics and astrophysics, this would be a nice book to start. Okay? Okay. Ito kasing discussion natin ni Griffiths, medyo siya. Mas gusto ko yung discussion ni Taylor and Wheeler. Kasi itong discussion ni Griffiths, nag-delve agad siya sa mga theoretical foundations. Yeah, theoretical. Ito masyadong theoretical, di ba? Pero si Taylor and Wheeler, ang starting point niya would be the invariant interval. Para magkakaroon ka na ng intuition na lahat ng distances ay invariant. Okay? Kapag mineasure mo yung distance and yung time between those events. Okay? So, I guess that's it. That's it for today. Any questions? Try nyo pa rin yung feel ko hindi ko na-deliver ng maayos yung examples. So, you try it yourself. Kailangan talaga dito ng handwork. Okay? Baka kasi feeling ko sa sarili ko intuitive na to sa akin. Tapos sa inyo, hindi pa siya ganun ka-intuitive. So, baka hindi ko na-explain ng maigi. Okay? So, again, try it yourself. Kung wala ng tanong,